So today we'll start with the three-phase AC systems. This is our final unit in this course on basic electrical engineering. Uh, so far we have studied single-phase AC systems. By single-phase AC systems, we simply mean that we have studied all these circuits uh, wherein we were having only one voltage source connected to one AC voltage source connected to an impedance or a load impedance. This load impedance can be a combination of RL and C. We have studied this type of circuit where we had only one single source, single voltage source. Uh, with AC systems, it is possible for us to connect multiple sources, multiple voltage sources, and still be able to deliver the load. Now, this load can also be distributed, or we can have the same load connected to different voltage sources. So with AC systems, what we have is we can have one voltage source connected to a load, or we can have a number of voltage sources be connected in different manners to the same load or to different number of loads. So we can have, say, for example, a system like this, wherein we have two voltage sources connected to two different loads. Fine. So this system wherein we'll be having two different voltage sources connected to a load will be known as a two-phase system. If we have uh, three voltage sources, you can try to rejoin then. इसको visible नहीं है. So you can have three different sources, three different voltage sources connected to a load. This can be a single load or different loads and different manner of connections. Fine. So uh, such a system will be known as a three-phase system. In general, we have a polyphase system with AC systems. What we can have is more than one with AC voltage sources. What with an AC system, what we can have is number of voltage sources. It's not restricted to two or three. You can have four, five, six number of voltage sources, or you can say generation points, which will be connected to your load. The load can be a single load, or it can be a number of loads again. And the property of these voltage sources is that these voltage sources are uh, equal in magnitude but differ in phase. Right? The magnitude of these voltage sources will be same. All these voltage sources will be having the same magnitude, but their phase will be different. So, say for example, in case of a two-phase system, what we do is normally these two voltage sources will be lagging each other by a phase difference of 90 degrees. In a three-phase system, what we have is we have these voltage sources lagging each other by 120 degrees. And also you can see that with a single phase you have a two wire system, with a two phase you have a three wire system. Okay, single phase you have two wires, in a two phase you have three wires, in a three phase you will be having four wires. So there will be a combination of you can actually no, this is a normal trend. You can have three phase three wire system also. We'll be studying that also today. uh, so normally with every phase there will be associated neutral wire as well, so that will act as your fourth, that will act as the additional wire and the return path for the flow of current. Fine. So with two phase you'll be having three wire systems, with three phase you'll be having four wire systems, with four phase you'll be having a five wire system, and so on. So in general, a polyphase system will be having more than one voltage sources. These voltage sources will be equal in magnitude but will be differing in phase from each other. And the purpose of this having polyphase system or number of phases is to deliver more amount of power at a much more economically as compared to a single phase system. Okay? So let us see the advantage of uh, so now among all of these three phase or five phase or seven phase. Uh, Firstly, we prefer to use odd number of phases. Fine. So you'll be coming across mostly across these terms: a three-phase system, a five-phase system, a seven-phase system. You will not come across two-phase or four-phase or six-phase because of certain um, because of the balance structure of uh, odd number of voltage sources. And then among these odd number of phase systems also, three-phase system has gained the most popularity, and it has a number of reasons why three-phase system has been preferred over all the other systems, including your single-phase system. So why three-phase system is used for transmission, for distribution, and even in industrial application, three-phase system is being preferred. So why is this? Because of a number of advantages the three-phase system offers over the single-phase system as well as over other polyphase systems. So one, it will be having it's easier to generate three-phase voltage as compared to generation of five-phase or seven-phase voltage, and even in comparison to single phase systems, three phase generation is much more easier as compared to single phase systems. Why? uh, now इसकी जो details है वो आप आगे जाके machines course में you'll be understanding that more in depth there, how single phase machines are a little bit more complicated, AC machines mostly, how we are talking about AC systems. So single phase AC generation is much more complicated as compared to three phase AC generation. So your both induction motors as well as synchronous motors or synchronous machines, they it is preferable to have a three phase source as compared to a single phase. It is preferable to have a three phase motor as compared to a single phase motor, because three phase motors have their own advantage and it becomes easier to generate even in comparison to a single phase generation. Fine. Uh, Two, with three phase available to us, we can always tap in single phase or two phase or even polyphase voltage from three-phase source. Fine. So always you'll be seeing you have your distribution is three-phase, but out of that you need only single phase to enter your residential or even commercial uh, जो भी आपके residential या commercial end users हैं or they only require single phase power supply. So you can always tap in from one phase that is available, and so a single phase is easily available to us from a three-phase voltage source. Or even if you need two phases from a three-phase source, you can even tap in two phases from that three-phase source. Or for even if you need more than two phases, if you need six phases or nine phases, you can easily manipulate this three-phase voltage source and be able to get a polyphase voltage at your end by some certain manipulations. So you can always tap in a single phase or a two phase from a three-phase source. Thirdly, it requires lesser insulation, lesser cost for transmission of same power. Now, as compared to a single phase source, a three phase source will be requiring lesser insulation. It will be requiring it will also require lesser material that will naturally reduce your cost of the system for transferring the same amount of power. Okay? Even though three phase will be having four wires, single phase will be having only two wires. But why is three phase more economical? Because of the fact that here four wires will be used to carry the same amount of power. So lesser amount of current has to flow through these wires. While as in a single phase system, only one wire and the return path will be carrying the same amount of current. It will be carrying the whole current through that single wire. So your cross sectional area of that wire will be much larger, and your material requirement will be much higher in a single phase as compared to a three phase. In a three phase, naturally, your thickness of wire will be reduced. It will be much thinner as compared to a single phase equivalent for carrying the same amount of power. Fine. So that actually results in lesser cost as compared to a three phase system. And if your wire is thinner as in a three phase system as compared to a single phase system, your insulation requirement will also be less. Fourthly, in a three phase system, harmonic component is lesser. ये जो मैं यहाँ पे लिख रहा हूँ 3 pi, this is actually a representation used for representing three phase, or you can use 1 pi to represent one phase. So in a three-phase system, your harmonic component is reduced. Now, harmonics, as I said to you earlier, harmonics are basically uh, voltage components that are introduced into your AC voltage that are actually having a frequency uh, that are multiples of your fundamental frequency component. Your fundamental frequency being 50 hertz. There will be other sine waves that will be introduced in this system that will be having a frequency of 100 hertz, 150 hertz, 200 hertz. That's actually multiples of your 50 hertz voltage actual fundamental wave frequency. Although the magnitude of these harmonics will be lesser, but they will cause distortion in the system. जो आपकी फिर actual waveform है, that will not be purely sinusoidal, that will be distorted sine. But with a three-phase system, what happens is that triplen harmonics are absent. Now, what does triple enharmonics here mean? Triple enharmonics means all those harmonics which will be having frequency of 3f, 6f, 9f, 12f. That means, in short, they are frequency multiples of 3. Fine. So all these harmonic components will be absent. Now, why does this happen? Because of the nature of the three-phase system. The three volt harmonics will be introduced in all the three phases, but they will cancel out the effect of each other, and the net harmonics will be reduced. So your triple harmonics will be absent in a three-phase system. There are actually a number of advantages of using a three-phase system, and as compared to a single-phase system, mostly in case of transmission lines. Uh, but most of these advantages you'll come across when you'll be taking up your power systems course in fifth semester. So uh, we will be more focused here on the analysis portion, how actually we mathematically analyze a three-phase system. Uh, as far as three-phase voltage generation is concerned, you'll study that in your machines course, and three-phase transmission distribution and what are its advantages, that will be studying in your power system course. So here we'll be only talking about the mathematical analysis of a three-phase system, how we can represent a three-phase system, and how it is how the voltage, current, and power equations are calculated in a three-phase system. So talking about the three-phase system now. So as I said to you, there will be three voltage. Uh, these three voltages are represented by uh, in a number of ways. You have three AC voltage. You can say VA, VB, and VC. This is one way of denoting these three phases, or the more general way that actually is used in practice is denoting the three phases by RYB. That's actually the color coding of these three wires, red, yellow, and blue. So whenever we are actually physically designing a three-phase system, so we take one wire of red color, another wire of yellow color, and third wire of blue color. Fine. So you can also represent them as VR, VY, and VB. One and the same thing, but we can use VA, VB, VC here. As I told you, these three phases will be having the same magnitude. So let us say the magnitude of these three phases is Vp. Okay, so we have three different AC sources, VA, VB, and VC. All the three sources have the same magnitude. Let that be Vp. And the phase difference between the three voltage sources is 120 degrees. Fine. So that means we were to draw phasor diagram. VA will be in this direction. That is the magnitude of this is Vp. It's located at an angle of 0 degrees. VB would be in this direction at an angle of 120 degrees, and VC would be in this direction at an angle of 240 degrees, or you can say 120 degrees out of phase from VB as well as VA. ठीक है. So यहाँ से जब हम calculate करेंगे, this will be 240 degrees. So we have three different voltages having a magnitude of Vp and 120 degrees out of phase from each other, or having a phase difference of 120 degrees from each other. Now, how to connect these voltage sources? There are actually two ways of connecting these voltage sources, and one way of connecting them is in star fashion, and another way is connecting them in the delta fashion. Okay? We have studied star and delta before. So what does that mean here? VA, VB, VC. ठीक है? This is just this अब ये simple wire diagram है. ये अब कोई phase difference नहीं है यहाँ पे. Although they still seem to look in 120 degrees. ये simply तीन wires हैं with three different voltage sources, and they are connected to one single point. Uh, so from here you can obtain a voltage of VA. From here you can obtain a voltage of VB, and from here you can obtain a voltage of VC. Fine. So you have actually three different voltage sources, three different AC voltage sources, and this is VP angle 0 degree. This is VB is VP angle to 120 degrees, and VC is VP angle 240 degrees. So you can connect them in this fashion, connected to a single point, that is the neutral wire. तो ये आपकी फिर न्यूट्रल वायर होगी. आपके पास चार वायर्स हैं in a three phase star system. So this is star connection. This is one way of connecting the three voltage. Another way of connecting the three voltage will be in delta fashion. So this can be VA, VP angle 0, VB, VP angle 120, and VC, VP angle 240. So the three terminals that will be accessible to us will be 1, 2, and 3. Now यहाँ पे जो volt, yes, there are three different voltage sources connected in a delta fashion. So this will be known as the delta connection. So you have two ways of connecting the three-phase voltage sources, three-phase AC sources. One is the star fashion, and another one is in the delta connection. With a star connection, you will always have a neutral point. So a star connection will be a three-phase four-wire system. This will be called a three-phase four-wire system. So whenever you will be said that you have a three-phase four-wire system, you will understand that the connections are made in star and there is a neutral point. But in case of a delta connection, you will be having simply a three-phase three-wire system. There is no common point between the three AC voltages. There is no neutral connection here. There will be no neutral path and for the direct for current to flow. Now, both these two connections have their own advantage and some disadvantage. We'll be studying. We have to actually analyze both these two systems, and we have that will be one uh, part of our study analyzing these star connection as well as delta connection. Now, before that, I'll let you know some terminologies that are associated with the system now. So you can see that there is a voltage potential difference, or you can say a potential difference or voltage between the phase and the neutral connection. Fine. So in case of a star connection, the potential difference between the phase and the neutral connection will be represented, it will be actually here VA only, and यहाँ पे तो ये VC होगा, and potential difference between this wire and this wire will be VB. ठीक है, because neutral wire जो है उसकी हम potential difference यहाँ पे 0 मान लेंगे. This is actually the reference node that we were considering in case of a single phase system. Uh, so these voltage that are available to us here, that is actually the voltage difference between the phase and the neutral. It is known as phase voltage. Yes. What are you asking? Hello. Yes. Now with a three-phase system, you have three different voltage sources. There are two possible ways in which you can connect them to each other. One way is connecting them in this fashion, fine, स्टार में जैसे हम करते हैं स्टार कनेक्शन. दूसरा जो है you can connect them in a delta fashion. In delta, you can see that there is no point of common coupling between the three voltage sources. There is no common node between the three voltage sources. But in case of a star connection, you can see there is a common node, and that is actually known as the neutral point. ठीक है. Now, what is अब यहाँ पे आपको क्या समझ में नहीं आया? Now, apart from this neutral terminal, the three terminals that are accessible to you is एक तो ये वाला टर्मिनल हो गया, दूसरा टर्मिनल ये हो गया, तीसरा टर्मिनल आपका ये हो गया. Now the phase difference or the potential difference between your terminal points, this is one terminal point that's actually accessible to you, this is another terminal point, and this is third terminal point. तो इन तीनों terminals पे कुछ voltage होगी with respect to the reference node, that is this point. So what is that voltage? So you can I'll not say whether that's VA, VB or VC. Whatever voltage is across your terminal node and your reference node or the neutral node, that is known as the phase voltage. Phase voltage, simply put, is the voltage between your uh, phase wires. These are known as phases actually. ये जो wires हैं अब आपकी between your phase and the neutral, it is known as the phase voltage. Now you can also find out potential difference or voltage between terminal and terminal. ठीक है, इस terminal और इस terminal के across भी कुछ voltage difference होगी. Now this voltage that you can actually find out, uh, whatever that voltage is, VT1 minus VT2, that will actually be VA minus VB in VC in this case. That is known as line voltage. So it is voltage between phase and a phase. So you have two phases. जो यहाँ पे जो terminals में बोल रहा हूँ यहाँ पे, the voltage between those two phases is known as the line voltage. We have two terminologies here, phase voltage and line voltage. Phase voltage is the voltage between a phase and a neutral. That will simply, for the star connection, that will be VA, VC, and between this and this it will be VB. ठीक है? Phase voltage is the voltage between the phase and the neutral. Now there is a voltage between a phase and a phase. इन दोनों phases के across भी आप देख सकते हो voltage difference क्या है. In this particular case, that will be VA minus VC. Fine. You can also say it is VC minus VA, and this is known as the line voltage. तो आप इन दोनों के बीच में calculate कर सकते हो. You can calculate the phase difference between these two terminals, or you can calculate the phase difference between this point and this particular point here. Fine. So this will be VB minus VC, and this will be VC minus VA. ठीक है? Now there are three phase voltage that are available to you, but there are six line voltage. How six? This is VA minus VC. It's also VC minus VA. VA minus VC it's generally represented इसको simply हम ऐसे represent करते हैं VAC. It's actually VA minus VC, and also available to is VC minus VA. That means VC minus VB आपके पास available है, क्योंकि AC voltage है तो यहाँ पे VA minus VC या VC minus VA you have to actually हालांकि इन दोनों में मैग्नीट्यूड तो सेम ही होगा, बट देयर विल बी अ फेज डिफरेंस. सो ये एक हो गया VAC VCA. ऐसे ही आपके पास VAB VBA है, and you have VBC VCB. Fine. So you have actually six line voltage: VCA, VAC, VAB, VBA, VBC, VCB. These are your line voltage. So these are voltage between a phase and a phase, and you have three phase voltage: VA, VB, VC. It is simply the voltage between uh, your phase and the neutral point. ठीक है? स्टार में तो ये एक्चुअली ऐसे अवेलेबल है आपको, तो आप हमेशा समझ सकते हो कि VA, VB, VC simply put is the phase voltage, and the difference between the phases VAB, VBC, VBC, VCA, VAC, so on, these are the line voltage. ऐसे आप डेल्टा में भी आप बोल सकते हो. This is your delta now. The three terminal points that are accessible to us in this case are these three terminal points. So VA, VB, VC. Simply put here, it is these will be the phase voltage in this case, and यहाँ पे जो voltage available है आपको, that's actually VA minus VC. So you can say VAC. यहाँ पे जो voltage आपके पास available है, that is VC minus VB. You can say VCB. यहाँ पे जो आपको voltage available है in this case, that is VB minus VA. So these are VAC या VCA, ऐसे ही VCB और VBC, and VBA or VAB. You can write them either ways. These are AC voltage. As I said to you, VAB is equal to minus VBA. So ये actually they'll be having the same magnitude, but they will be out of phase from each other. ठीक है? तो यहाँ पे जो वोल्टेज आपको अवेलेबल है एट द टर्मिनल्स इन केस ऑफ अ डेल्टा कनेक्शन, दैट आर एक्चुअली लाइन वोल्टेज. तो ये तो फेज वोल्टेज और लाइन वोल्टेज हो गई. ऐसे आपके पास फेज करंट एंड लाइन करंट है. अब फेज करंट लाइन करंट क्या है? we'll explain that from a delta connection. Now there will be some amount of current flowing in this wire. Let that be IB. There's some amount of current flowing in this wire, let that be IA. There's some amount of current flowing in this wire, let that be IC. ठीक है, अब ये AC currents है, so they are actually changing direction. So you have three currents in three phases. So simply put, from the delta, you can see that these three currents in three different phases are known as phase currents. Then there will be current in these three lines as well. तो मैंने लाइन स्पेसिफिकली ले लिया. अब इसमें करंट क्या होगी, यहाँ से अगर आई ए जा रहा है और यहाँ से आई सी जा रहा है, तो द करंट दैट विल बी फ्लोइंग हियर विल बी आई ए माइनस आई सी. ऐसे यहाँ से करंट आई सी माइनस आई बी होगी, और यहाँ से जो करंट होगी दैट विल बी आई बी माइनस आई ए. So you can see actually there is some amount of current flowing into these terminals or these lines as well. These currents here are known as the line currents. I'll simply write them as IAC, ICB, IBA. ठीक है, ऐसे ही आपके पास ICA, IBC, IABA भी आप लिख सकते हो. They'll be again having the same magnitude but will be out of phase from each other. क्योंकि यहाँ पे actually direction of current does not mean anything in an AC system because it will be actually changing direction. IA कभी इस डायरेक्शन में होगा, IA कभी इस डायरेक्शन में होगा. तो यहाँ से कभी करंट IAC होगी, कभी करंट ICA होगी. ठीक है. So these currents now in the lines here, simply put, are known as the line currents, and the or you can say actually the difference between these phase currents that we have seen in different phases in a delta connection, they are known as phase, they are known as the line currents. ठीक है, तो जो phases में currents है उनको तो phase current बोलते हैं, but उनके difference को हम line currents बोलते हैं. Phase current and line current is visible from a delta, and phase voltage and line voltage can be distincted from a star connection. इसका क्या मतलब है actually? Now coming back to the star connection, यहाँ पे जो line है, this is your line, that is actually your terminal जो आपको बाहर निकल रहा है. This is one terminal, ये आपका दूसरा terminal है, ये आपका तीसरा terminal है. अब यहाँ से अगर करंट आई ए फ्लो कर रही है, यही करंट तो यहाँ लाइन में भी जा रही है, तो यहाँ पे आपकी जो फेज करंट है that is equivalent to the line current. Similarly, in case of B phase, you can see whatever amount of current is flowing from here, the same amount of current is also going into this particular terminal, or you can say line. तो आई बी यहाँ से भी है और आई बी यहाँ से भी है. ऐसे ही आई सी यहाँ से भी है और आई सी आपकी यहाँ से भी है. So in case of a star connection, you can see that phase current and line current, they are same, but phase voltage and line voltage, they are not same. Now we'll actually take up first the star connection and analyze it. So I have defined to you four different terms: phase voltage, line voltage, phase current, line current. अब किस में phase voltage क्या है, किस में line voltage क्या है, phase current क्या है, line current क्या है, अभी वो हमने अभी नहीं देखा है. Just remember the terms. Phase voltage is simply the voltage between a phase and a neutral, while as line voltage is the potential difference, or you can say the voltage across two different phases or two different lines. Fine. Phase voltage, a voltage between a phase and a neutral point. Line voltage, voltage between two different phases or two different lines also you can call it now. Phase current is simply the current flowing through a particular phase, and line current is actually the current flowing through a certain line. ठीक है, अब यहाँ पे एक्चुअली दो टर्म्स और हैं, फेज और लाइन की भी। फेज और लाइन कब सेम होगी या फेज और लाइन कब डिफरेंट होगी, वो भी हम एक्चुअली विल सी दैट इन when we analyze these star connections and delta connections. So first of all, we are analyzing the star connection. VA, VB, VC. You can name anything VA, VB, VC here, but this thing will keep fixed that VA is VP angle 0, VB is VP angle 120, and VC is VP angle 240. तो ज्योमेट्रिक अलाइनमेंट इनका मैटर नहीं करेगा, इनका इलेक्ट्रिकल अलाइनमेंट मैटर करेगा. Whether they are geometrically 180 degree different from each other or 190 या कुछ भी हो, electrical angle between these three is they are having a phase difference of 120 degrees from each other. We are not concerned with the geometric alignment of these three different phases here. So now we have a star connection. So star connection, as I said to you, it is a three-phase, four-wire system. You have a common point in case of a star connection, जहाँ पे तीनों voltage sources connect हो रहे हैं, ठीक है? And that common point is known as the neutral point. We'll take it equal to the voltage at this point will be taken equal to 0. You can actually also find that out. It is actually equal to 0. We'll see into that as well. So a system, a three-phase system is said to be balanced if the magnitude of VA is equal to magnitude of VB is equal to magnitude of VC, and obviously all the three will be 120 degrees apart from each other. 120 degrees electrically apart, ठीक है? So in a normal three-phase system, mechanically apart only in case of machines. Mechanical angle is also very important between the different phases, but apart from that, in case of power systems or in any other system, the mechanical angle between these phases does not matter to us. ठीक है? So these three systems are balanced. Yes, yes. जो वहाँ पे आपके मोटर्स होते हैं, इंडक्शन मोटर्स, वो थ्री फेज मोटर्स होते हैं. थ्री फेज मोटर्स की अपनी एडवांटेज है और सिंगल फेज मोटर्स, जैसे मैंने आपको बताया, वो जो एडवांटेज वगैरह है थ्री फेज मोटर्स की, वो आप मशीन कोर्स में पढ़ लोगे. So you have a three phase system. It is said to be balanced if the magnitude of VA, VB and VC is same and they are 120 degree apart from each other. It is said to be unbalanced if magnitude of VA is not equal to magnitude of VB is not equal to magnitude of VC, even though the phases will still be 120 degree apart from each other. But our analysis is going to be around balanced systems only. We'll be assuming that the three systems will be having a balanced, will be having equal magnitude. Because we actually prefer to have the system balanced. Fine. If your system is actually unbalanced, it may result in certain faults that we do not want in our system. Fine. So जो fault जो भी occur हो रहे हैं because of unbalance वगैरह, again you'll be seeing that in case of power in your power systems course. Here, in case of star system, in case of a star connection, VA, VB, and VC simply represent the phase voltage. So you have VA, VB, and VC equal to VP angle 120, VP angle 120, and VP angle 240 degrees. Fine. So these are the three phase voltage in a star connection, VA, VB, and VC. And these three are also called to be imbalanced if VA plus VB plus VC is equal to 0. Why? They are in they are called they will be balanced if VA plus VB plus VC is equal to 0. So you can actually substitute the values here. You can substitute VA equal to VP angle 120 plus VP angle 0 plus VP angle 120 plus VC angle 240 degrees, not VC, VP angle 240 degrees. VP आप कॉमन निकाल सकते हो, so अंदर 1 angle 0 plus 1 angle 120 plus 1 angle 240 आएगा is equal to 0. So you can see this will come out to be 0. So VP into 0 is 0. So hence actually you can see that VA plus VB plus VC is equal to 0. So therefore this system is a balanced system. The summation of these three voltages is equal to 0. VA plus VB plus VC is equal to 0 in a balanced star connection. The summation of three phase voltage in a star is equal to 0. Yes. 1 angle 0 plus 1 angle 120 plus 1 angle 240 आप कर लो तो ये 0 आएगा. ठीक है, कैलकुलेटर है आपके पास. ठीक है. Whether you show it as a positive angle or you show it as a negative angle, it will not matter. You can even show it as minus 120, minus 240. ठीक है, एक ही बात है. So if we were to plot the sinusoidal variation of these three voltages, so VA, this is VA having a magnitude of VP starting from an angle of 0 degrees. We'll assume that VB and VC, they are lagging VA. So VB will start somewhere around 120 degrees. तो VB ये होगा and VC will be starting somewhere around 240 degrees. 240 कहीं पे यहाँ पे होगा, so it will start from here. So this will be the sinusoids. If you were to plot the three voltage VA, VB, and VC, you can show them in this fashion. VA is starting from an angle of 0 degrees, VB is lagging behind VA by 120 and VC is lagging behind VA by 240 degrees. ठीक है, जैसे मैंने आपको बताया, आप प्लस 120 लो या माइनस 120 लो, it will not actually affect our calculations. That in either cases your system is still balanced, your system is still a three-phase system. Fine. But this is actually preferred to use. Convention यही है कि आप VB और VC को you show them you show it lagging behind the phase volt, the VA voltage. ठीक है. Fine. Yes. So from our system also, as I told you, if current flowing in this phase is IA, current flowing in this phase is IC, current flowing in this phase is IB. What is the current flowing in this line? It is still the same amount of current will be going here, that is IA. Same amount of current will be going here, that is IB. And same amount of current is going here, that is IC. Phase voltage are VA, VB, VC. Phase currents are IA, IB, IC. Line currents are the same, IA, IB, IC. ठीक है. लाइन करंट हम किस करंट को बोलते हैं जो आपके टर्मिनल में एक्चुअली करंट आपको एक्सेसिबल है, दैट इज योर लाइन करंट. फेज करंट उसको बोलते हैं जो आपके फेज से एक्चुअली जो आपके वोल्टेज सोर्सेज का जो करंट प्रोड्यूस हो रही है. ठीक है. So in case of a star connection, you can see that whatever amount of current is produced by a certain voltage source, the same amount of current is going into that line as well. So in case of a star connection, phase current in general IP is equal to line current, that is IL. Fine. Now what about the line voltage? Line voltage, जैसे मैंने बताया, it is the difference between two phases. So there are three phase voltage, but there are six line uh, voltage. So there are six line voltage, that's VAB, VBC, VCA, VBA, VCB and VAC. Now what is VAB? VAB is VA minus VB. VA को हमने क्या लिया था? VA को हमने VP एंगल 0 डिग्री लिया था माइनस VB. अगर हम ऊपर वाले ग्राफ की बात करें, इट इज लैगिंग बिहाइंड बाई माइनस 120 डिग्रीज. So this is VP angle minus 120 degrees. Fine. So VP angle, तो अंदर क्या रहेगा? 1 angle 0 minus 1 angle 120 degrees. So you can actually calculate that. 1 angle 0 minus 1 angle minus 120 degrees. Yes. मैंने बताया आप माइनस लैग कराओ या लीड कराओ एक ही बात है. इसमें यहाँ पे तो लैग कर रहा है. VB is lagging VA. VB is lagging VA by 120 degrees. लैग का मतलब है ये 120 डिग्रीज के बाद स्टार्ट हो रहा है. अगर ये लीड कर रहा होता तो फिर ये यहाँ पे होता VB, यहाँ पे माइनस 120 से स्टार्ट हो रहा होता. VB फिर ऐसे होता. ठीक है. So this will come out to be so VA minus VB is equal to VP angle 0 minus VP angle minus 120 degrees is equal to VP. कॉमन निकाल के अंदर 1 angle 0 minus 1 angle minus 120 degrees. Fine. So 1 angle 0 minus 1 angle 120 degrees, when you will calculate that will come out to be 1.73 angle 30 degrees. Fine. So this means this is 1.73 VP angle 30 degrees. So VAB कितना आया? 1.73 angle VP 30 degrees. VBC Hello. VBC will be equal to VP. VBC is equal to VB minus VC, that is VP angle. VB is minus 120 minus VC, that is minus VP minus 240 degrees. तो वैसे ही VP कॉमन निकाल के so this will come out to be 1.73 VP angle minus 90 degrees. VCA आप निकाल सकते हो, फिर VCA will be VP angle minus 1 minus 240 minus VP angle 0 degrees. So this will come out to be 1.73 angle minus 90 minus 210 degrees. ठीक है. VP कॉमन निकाल के अंदर 1 एंगल minus 240 minus 1 एंगल 0 आएगा. So this will be equal to 1.73 VP angle minus 210 degrees. So let me put this here now. VAB आपका 1.73 VP angle 30 degrees आया. Instead of writing 1.73, you can simply write root 3 VP angle 30 degrees. Root 3 VP angle minus 90 degrees. VCA is VC minus VA, that will come out to be root 3 VP angle minus 1 minus 210 degrees. VBA is simply minus VAB actually, so that will be root 3 VP 30 minus 180 degrees, तो minus 150 हो गया. VCB is equal to minus VBC. VAC is equal to minus VCA. VBC हमने root 3 VP angle minus 90 degrees निकाला. root 3 VP minus 90 minus 180, that is means minus 270 degrees. root 3 VP minus 210 minus 120, that is minus 390. Minus 390 means minus 30 degrees. ठीक है, आप माइनस में दिखा लो या पॉजिटिव एंगल्स दिखा लो, एक ही बात है. माइनस 210 ऑल्सो मीन्स अगर हम माइनस 210 की बात कर रहे हैं, दैट इज इन दिस डायरेक्शन, वो प्लस 150 हो गया. ठीक है, तो आप यहाँ पे माइनस 210 की जगह पे 150 भी लिख सकते हो. माइनस 90 की जगह पे आप 270 भी लिख सकते हो. माइनस 150 की जगह पे आप 210 भी लिख सकते हो. माइनस 270 मीन्स सिंपली प्लस 90 डिग्रीज. माइनस 30 मीन्स सिंपली प्लस 330 डिग्रीज. फाइन. ठीक है, तो ये आपकी लाइन वोल्टेज है. सो यू कैन सी द मैग्नीट्यूड ऑफ लाइन वोल्टेज, द मैग्नीट्यूड ऑफ लाइन वोल्टेज, द मैग्नीट्यूड ऑफ फेज वोल्टेज. VA, VB, VC हमने ये लिया था. VA इज VP एंगल 0 डिग्रीज. VB इज VP एंगल minus 120 degrees. VC is VP angle minus 240 degrees. You can take minus plus, कोई फर्क नहीं पड़ेगा. It will not change our system. uh, आपके पास तीन फेज वोल्टेज हैं, तीन वेक्टर्स हैं, VBA, VB, VC. Whether you want to say VP is, if VA is VP angle 0, you want to say VB is uh, ये VB है, say for example ये VC है. You can say VB is VP angle minus 120, or you can even say VB is VP angle 240. तो एक ही बात है. VC यहाँ पे VP angle आप 120 लो, या फिर आप इसको VP एंगल माइनस 240 लो, वो एक ही बात है. फाइन, इट डज नॉट चेंज अवर सिस्टम. हमारी जो तीन वोल्टेज है वो स्टिल सेम ही है. अब आप पॉजिटिव एंगल लेना चाहते हो या नेगेटिव एंगल लेना चाहते हो, दीज आर स्टिल द सेम वेक्टर्स. दे विल नॉट एक्चुअली हैम्पर, दे विल नॉट चेंज आवर कैलकुलेशन तब भी वही रहेंगे. फाइन. अब VB और VC यहाँ पे खाली इंटरचेंज हो रहा है. अपार्ट फ्रॉम दैट नथिंग एल्स विल हैपन. But if you want to sinusoidally show them, the convention is to show VB and VC lagging behind VA. So sinusoidally हम इस ऐसे दिखा सकते हैं. But even you can show them leading VA. It's not something that is fixed. ये सिर्फ एक convention है. आप VB और VC को lead कराओ VA से. That is also up to you. You can even take VB as VP angle 0 degrees. You can take VB as the reference. You can find out VA and VC. आप कोई भी रेफरेंस लो, आप माइनस एंगल लो या प्लस एंगल लो, वेक्टोरिकली, सिंस वी आर नॉट डूइंग एनी साइनोसाइडल कैलकुलेशन, तो हमारी जो कैलकुलेशंस है वो दे विल स्टिल बी द सेम, दे विल नॉट चेंज. विल स्टिल बी गेटिंग 6 लाइन वोल्टेज. उनके नोटेशंस अब डिफरेंट हो सकते हैं. यू आर जस्ट इंटरचेंजिंग दोज नोटेशंस, बट यू विल स्टिल बी गेटिंग 6 लाइन वोल्टेज दैट विल बी at a certain angle from each other. From this star connection, we have seen that the magnitude of phase voltage in general is Vp. Fine. While as the magnitude of line voltage is equal to root 3 Vp. ठीक है. Root 3 Vp means that your line voltage is root 3 times the phase voltage. जबकि line current and phase current in the star connection are same. So as far as the star connection goes, line current and phase current are same, but phase voltage and line voltage, they are not the same. If phase voltage is Vp, having a magnitude of Vp, the line voltage will be having a magnitude of root 3 times Vp. So in case of a star connection, IL is equal to IP, while as Vp is VL is equal to root 3 times Vp, where Vp is the magnitude of phase voltage. So line voltage is having a magnitude. ये magnitudes की बात हो रही है. ठीक है. Although phase current and line current, they are exactly same in case of not only magnitude, they are even in phase, they are the same. So phase current, line current are same in case of star connection, but the line voltage is root 3 times Vp in case of a star connection. So ये एक important चीज़ है यहाँ पे. So if you want to increase the voltage, you are actually, what is the voltage that you are generating? You are generating VA, you are generating VB, and you are generating VC. For example, this is the voltage that you are generating. Now if you connect them in a star fashion, the line voltage that will be available to is root 3 times. That means if you want to extract more voltage without changing any generation, you can always tap into the line voltage and instead of tapping into the phase voltage. ठीक है. You can take output from here between your phase and neutral point. आपके पास, say for example you are running a 3-phase 4-wire system. All those 4 wires are accessible to you. If you tap between the phase and the neutral point, uh, you will get a voltage of Vp. Fine. But if you tap between a phase and a phase, you will get a voltage of root 3 times Vp. ठीक है. So sometimes if we require more voltage in certain applications, we can always tap into the line voltage and feed our system through the line voltage. Uh, so yeah, root 3 Vp between any two lines, between any two phases, the voltage will be root 3 times Vp. The magnitude of voltage will be root 3 times. This was your, this is your phasor diagram between the phase voltage Va, Vb, Vc. इसी पे मैं बना लेता हूँ. This will be your, ये तीनों इक्वल मैग्नीट्यूड्स के हैं. Va, Vb, Vc. Va is Vp angle 0, Vb is Vp angle minus 120, Vc is Vp angle minus 240. Fine. And VAB, as you have calculated from here, VAB is root 3 times root 3 Vp angle 30 degrees. So VAB is here. ये इसका magnitude but root 3 times है. So that means if this is Vp, this has a magnitude of root 3 times Vp. तो ये आपका VAB है. It is located at an angle of 30 degrees. If this is VAB, VBA will be simply opposite to this. ठीक है. ये again magnitude इसका root 3 Vp है. This is 30 degrees. Therefore this is at an angle of 180 from that. That means ये आपका 210 है, या फिर आप minus 150 भी बोल सकते हो. ठीक है. ये आपका VAB हो गया. VAB, VBC. VBC will be actually 120 degrees from VAB. Let me just, VBC is at an angle of minus 190. VBC इस डायरेक्शन में, VBC आपका इस डायरेक्शन में, it is in this direction, having a magnitude of root 3 Vp at an angle of minus 90 degrees. So ये आपका VBC है. तो VC भी आपका यहाँ से होगा. So this is VCB. This is at an angle of minus 90 degrees. And we have the third, that's VCA. It is root 3 Vp angle minus 210 degrees. VCA, it is minus 210 or you can say plus 150. ये 120 है तो 150 यहाँ पे होगा. So this is VCA. तो VAC आपका इस डायरेक्शन में होगा. You have 3 phase voltage but you have 6 line voltage, VAB, VBC, VCA and VBA, VCB and VAC. इन सब के बीच में, लाइन वोल्टेज के बीच में जो वोल्टेज एंगल होगा, that will be 60 degrees. They will be 60 degrees apart from each other. You can even see they are 60 degrees apart. ये plus 30 है, ये minus 30 है, ये minus 90 है, this is minus 150, this is minus 210 and minus 330 or plus 90 degrees. So this is about a Y connection, phase current, line current is same, but line voltage is root 3 times Vp. There are 3 phase voltage. There are 6 line voltage. The phase voltage are 120 degree apart from each other, but the line voltage they are 60 degrees apart from each other because there are actually 6 line voltage. Uh, Now analyzing the delta circuit, VA, VB, and VC are the three phase voltage. IA, IB, IC are the three phase currents. We have phase voltage here, VA, VB, and VC, and we have phase currents. Phase currents are IA, IB, and IC. Okay. Now what about line voltage? That's VAB, VBC, VCA, VCA, so on and so forth. That's actually the voltage between a line and a line. ठीक है. तो एक तो हो गया कि आप you can find out the voltage at this particular point, you can find out the voltage at this particular point. So एक तो VAB है, दूसरा VCB है, so you can find out the difference between the two, or you can directly see since this connection here is in parallel with this VB connection, तो यहाँ पे जो voltage होगी that will be simply VB. Fine. ऐसे ही यहाँ पे और यहाँ पे आप तो एक तो यहाँ से आप डिफरेंस बिटवीन द टू वोल्टेज VBC, डिफरेंस बिटवीन द टू वोल्टेज VCA, उन दोनों का डिफरेंस कर सकते हो. और इन अदर वर्ड्स सिंस दिस कनेक्शन इज इन पैरेलल विद दिस पर्टिकुलर कनेक्शन, सो यहाँ पे जो वोल्टेज है दैट विल बी VC. ऐसे ही अगर आपको इसके इस पॉइंट और इस पॉइंट के बीच में वोल्टेज देखनी होगी, so you can find out the voltage difference here, you can find out the voltage difference here, calculate that, or simply put it is equal to this particular voltage, that is VA in this case. ठीक है. तो यहाँ पे जो लाइन वोल्टेज होंगी और फेज वोल्टेज होंगी in case of a delta circuit, they will actually be same. So the phase voltage and the line voltage in this case will be same. ठीक है. So VAB is VBC, VCA, VCA, VBC, and VAC. They'll be taking the same uh, uh, they'll be taking the same magnitude as that of the line voltage. अब आपको एक्चुअली इंडिविजुअली वो देखना भी होगा कि कौन कहाँ पे क्या वोल्टेज थी और कौन लाइन वोल्टेज किस phase voltage के बराबर है. But as far as the magnitude will be concerned, now in this case the magnitude of the phase voltage and the line voltage will be same. But as far as the phase currents and line currents go, they are not same in this particular case. In the individual phases, the phase currents are IA, IB, and IC. Now in this particular phase, the current will be IA minus IB in this particular line. In this particular line, the current will be IB minus IC, and in this particular case, the current will be IC minus IA. ठीक है. अब IA, IB, IC का value तो हमें exactly we do not actually know the values of IA, IB, IC unless there is a load connected. Only then we can calculate the values of IA, IB, and IC. But from here you can actually say that at least you have established that in case of a delta connection, the phase current and the line current will not be same. ठीक है, तो हम एक्चुअली जब हम लगाएंगे कुछ लोड, तो हम देख लेंगे कि वो लाइन करंट विल बी एक्चुअली रूट 3 टाइम्स द फेज करंट. So from the two circuits, we have to actually analyze them with the load also. उससे ज़्यादा clear हो जाएगा. From the two circuits, but so far what we have studied is you can have the three phase voltage connected either in a star fashion or in a delta fashion. In a star fashion, you will be having uh, a point of common coupling that is known as the neutral point. So you'll be having a three-phase four-wire system. But in case of a delta, you'll be having only three connections, three wires. So it's known as a three-phase, three-wire system. In case of a star, the line currents and phase currents, they will be same. Uh, while as in case of a delta, the phase voltage and the line voltage will be same. ठीक है. अब कौन सी लाइन वोल्टेज किस फेज वोल्टेज के बराबर है वो तो हमने अभी कैलकुलेट नहीं किया, but the magnitude of those phase voltage and line voltage will be same that we have directly seen from the circuit diagram. Secondly, uh, in case of a star connection, the line voltage is root 3 times Vp. ठीक है. So अगर आपको if you want to have extra voltage from uh, in a for any application, you can always tap into two phases rather into tapping between a phase and a neutral. ठीक है. तो some so एक तो हो गया illegal तरीके से करना, दूसरा लीगल तरीके से करना. That is these are two different things, right? So there may be cases where you will have to where you actually have access to three-phase system and you want to want more voltage across two different phases, so you can tap into two different phases and have more voltage available to you. Another case is that illegally resorting to hooking extra or tapping into two different phases, that is something different. But all in either cases, you can obtain more voltage by tapping into two phases uh, rather than tapping into a phase and a neutral. While as in case of a delta connection, the line volt current and phase current, they are not same. They are actually the line current will be root 3 times the phase current. Without actually knowing the load, we cannot calculate current. If there is no load, the current will be zero. So we'll have to actually have some load here and then find out the value exactly of the line current. So this will be doing actually now in the next session, but we have now four different types of connections that we have to study. These are known as the YY connection, the Y delta connection, the delta Y connection, and the delta delta connection. ठीक है, इसका क्या मतलब है? We'll be taking four different systems. In one system, our three-phase source is connected in star, as well as our load will be connected in star. So we have VA, VB, VC, the three voltage, and we'll be having three impedances. They are also connected in a star fashion. So we'll be analyzing one this circuit. Secondly, we'll be having the three-phase voltage sources will be in a star connection, while as loads will be in a delta. So our uh, source voltage, they are connected in a star fashion, while as our loads, they are connected in a delta fashion. Similarly, then we'll be having a delta star connection, where our source will be connected in delta, the loads will be connected in star, and finally, fourth one will be the delta delta connection, where our load as well as the source voltage, they will be connected in a delta. So we have four different circuits. With all these four different circuits, we have to analyze what will be the voltage, what will be the current, what will be the power. So we have to calculate all those factors, and then we उसके बाद इन्हीं different combinations पे हमें numericals वगैरह करनी है. So that will actually wrap up this course. But अब यही these four different connections, they will actually take us, each connection will take almost one lecture, 1 to 2 lectures will it will take 1 to 2 lectures on each and every connection. फिर हर किसी कनेक्शन की फेज वोल्टेज, हर किसी कनेक्शन की लाइन वोल्टेज, हर किसी कनेक्शन की फेज करंट, हर किसी कनेक्शन की लाइन करंट, उनकी जो भी इक्वेशंस आएंगी, वो सब आपको एक्चुअली दैट यू हैव टू रिमेंबर. So